Hello students, welcome to my class. In this video, I'm going to begin the chapter Coordinate Geometry. It is one of the important chapter in your current syllabus, and also you have studied this chapter in the 9th standard also, the same chapter Coordinate Geometry. So this is the 7th chapter for you in your syllabus. Now it is necessary to recall the concepts of what you have studied in the 9th standard. The first thing you have studied in the 9th standard is Cartesian plane. It is also called as coordinate plane and also called as XY plane. And also you know this one. It was developed by the French mathematician René Descartes. And the second most important thing you have studied in the 9th standard is locating the position of a point when coordinates are given to you. And the third most important thing is identifying the position of a point when a point is already given in a Cartesian plane. Means already you know that how to define the position of a point in a Cartesian plane and how to locate the position of a point when its coordinates are given to you. I think you know that one. There are two coordinates. One is x coordinate or abscissa, and another one is ordinate. It is also called as y coordinate. So to specify the position of any point in a coordinate system, we must have two coordinates. One is x coordinate and y coordinate. Now I'm going to explain briefly all the basic things what you have studied in the 9th standard. Now let us begin this chapter by defining what is coordinate geometry. So now look at the lines what I have given initially for you. So it is like this. Coordinate geometry has been developed as an algebraic tool for studying geometry of figures. It helps us to study geometry using algebra and understand algebra with the help of geometry. Okay, so now let us clarify one thing for you. Geometry and algebra both are branches of mathematics. Mathematics is a branch of science, and the subject mathematics itself has sub branches. Arithmetic, algebra, geometry, like that. These are all the sub branches of mathematics. Among these two, I am going to consider algebra and geometry. Algebra means what? In the chapter algebra, we have studied the chapter polynomial. Actually, it comes under algebra. So in this chapter, actually, we are going to deal with what? Algebraic expressions. Algebraic expressions consist of what? Constants, variables, okay, like that, algebraic expressions. And the second one, that is geometry. Geometry means what? In the geometry we are going to deal with geometrical figures. Geometrical figures consist of what? It consists of sides, angles, okay, and moreover that is length, breadth, dimensions, area, volume, like that. So now if we combine both algebra and geometry, means actually we are going to make use of algebra to study geometry. Okay, because if we apply algebra to study geometry, it will be very helpful for all the things, means for doing the problems and for understanding purpose, like that. When we use algebra, the concept of algebra and geometry, then it will form a new branch of mathematics. The branch is actually called as coordinate geometry. So that's why in the first two lines I have given understand algebra with the help of geometry. Okay, so geometry and algebra, both are going to combine here. So a new branch is formed. It is actually called as what? Coordinate geometry. So now in the previous year you have studied the basic concepts of coordinate geometry, and later I'm going to discuss the same things with you. Before that, now let us see what are the topics involved in this chapter. So now look at here, I have shown for you here. In this chapter mainly we are going to study first one, a distance formula. Okay, distance formula, the first topic. Second topic is section formula. Second topic, section formula. And the third topic, area of triangle. Okay, so in these three topics, the third topic, area of triangles, actually this is deleted in this academic year actually. Okay, so in this year actually syllabus is reduced for you. Okay, I have sent this one already for you, and for confirmation once again I am going to show for you. So this is actually the deleted content. Okay, class, so this is for class 9 actually. Now look at it, this is for class 10. Okay, in the first chapter, Euclid division lemma. Okay, it's already known for you. So now look at here in the chapter coordinate geometry. Okay, so now look at here, this is a trigonometry, introduction to trigonometry, heights and distance. Okay, I think okay, so now look at here, this is actually coordinate geometry, area of triangle. Okay, this topic is actually what removed from your syllabus. That's why I'm not going to discuss about that area of triangle. If you just study distance formula and section formula, it will be enough for this academic year. So you need to understand the distance formula, derivation, after that problems on distance formula, and the second one is section formula and derivation of section formula. After that we are going to solve problems on section formula. So if you study these two topics, this chapter will be completed. Okay, so now before beginning this chapter, I'm going to convey the basic concepts of this chapter, coordinate geometry. Okay, all these things are already studied in your 9th standard, but I think you have forgotten all those important points. Okay, what is Cartesian plane and how it is formed, like that. But I'm going to recall once again for you. Okay, you can open the 9th standard textbook and you can read once. Then you all the concepts will be recalled for you. But even though I'm going to explain all those things here, if you listen this class carefully, you will recall all those concepts. Okay, so now let us begin. So now look at here. So the last year you have seen a plane to locate the position of a point in a coordinate plane, and that actually called as, it is also called as coordinate plane. There are three different names for that plane. So remember all these three names. One is Cartesian plane, and another name is coordinate plane, and it is also called as what? XY plane. Okay, remember all the three names may be used, but most of all times I'm going to use the word Cartesian plane or coordinate plane. Okay, so now look at the first point. Cartesian plane was developed by a French mathematician, René Descartes Cartesian. Okay, so some information about René Descartes Cartesian is given in the textbook of 9th standard for you. He is the first mathematician who developed the Cartesian plane. So in honor of his name, the plane is also named as Cartesian plane. Okay, the name Cartesian is because of the French mathematician René Descartes. Okay, and second thing, now let us see how it is formed. Cartesian plane consists of two mutually perpendicular lines intersecting at their origins. Okay, it's actually made of two number lines. You know what is number line? Okay, it is a straight line on which all the real numbers are placed at the middle. 0 is present on the right side of 0, positive numbers are present in the left side of 0, negative numbers are actually arranged. Okay, that is actually real line. So if you consider two real lines and if you place those two lines mutually perpendicular to each other, okay, then so that one more important condition is, now look at here, intersecting at their origins. This is very important. Okay, intersecting at their origins, you have to place those two lines perpendicular to each other. Moreover, they must intersect at their origins. Okay, now first I will show the figure how it look like actually. Okay, the figure is actually below. Okay, so now look at here, this is actually the figure. Okay, so now just look at this figure only. Okay, so just look at this figure, don't concentrate on this figure, I'm going to explain this one later for you. Just look at this figure. Okay, so now look at here, this is one real line. Okay, and this is another real line. Okay, so these two lines are going to intersect at this point actually. Okay, so now this line and this line both are actually number lines, they are going to intersect at this point. Okay, so now let us see the next point, what is actually the next point. So now look at here, the third point actually, the horizontal line x dash is called as x-axis, whereas the vertical line y dash is called as y-axis. Okay, so now look at here, horizontal line means this one. Okay, so this line is actually called as horizontal line and it is named as x-axis, it is given for you here. Okay, it is x-axis, and the vertical line means this one. Okay, so this is actually called as what, vertical line, and this line is actually called as y-axis. Remember, horizontal line x-axis, so vertical line is called as what, y-axis. And the next point is the point of intersection of x-axis and y-axis is called as origin, and it is denoted by letter O, capital letter O. Okay, so now look at here, the point of intersection of both axes, this is actually the point of intersection. So this is actually called as what, origin, and it is denoted by the capital letter O. Actually it is not mentioned in the figure, I'm going to convey for you. Okay, it is actually named as O. Okay, so if you name this one as O, then it will become x. Okay, O and then x dash, and this will become y, O, y dash. Okay, so that's why the middle portion means the point of intersection is actually called as origin, and the coordinates of origin are actually 0, 0. I have given this one in the next point. And the next one, ox positive x-axis, ox dash negative x-axis, so oy is called as positive y-axis, and oy dash is called as negative y-axis. Now look at here, so from this is actually O. Okay, this is actually x, O to x, this all the positive numbers are arranged from here to here, so that's why it is called as what, positive x-axis. And this is O, and this is x dash. Actually O to x dash, negative numbers are arranged. Okay, so that's why it is called as negative x-axis. Similar sense, oy, it is called as positive y-axis, so oy dash, it is called as what, negative y-axis. Okay, now move on to the next point. It says like this, x-axis and y-axis divide the plane into 4 equal parts. Each part is called as a quadrant, and they are numbered from ox in the anti-clockwise direction, and as first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, it's already known for you. Okay, so now when we arrange these two lines like this, means mutually perpendicular to each other, it seems to be like this entire plane. Okay, this entire plane is divided into 4 equal part. Okay, so this is the first part, and this is the second part, and this is the third part, and this is the fourth part, and each part is actually called as quadrant, because we have divided a entire portion into 4 equal parts, means one part is actually called as quarter. Okay, if you divide the entire region into 2 equal parts, each parts are actually called as halves. Okay, halves, halves. Okay, but when we divide a entire part into 4 equal parts, each part is actually called as quarter. Okay, so that's why the name quadrant. Okay, that's why, remember, so each part is actually called as quadrant, and these quadrants have to be numbered in a particular way. Okay, so for understanding purpose, now look at here, this is actually what, ox, positive x-axis, ox, from ox in the anti-clockwise direction. Anti-clockwise direction means this is ox, anti-clockwise direction means you need to move like this. Okay, if you move in this direction, it's called as anti-clockwise. Suppose if you move from the ox, positive x-axis, if you move in this direction, it is actually called as what, clockwise direction. Okay, so actually it is mentioned what, anti-clockwise direction. So that's why from this point, if you move in the anti-clockwise direction, then you have to number the quadrants. Okay, so now look at here, if you move in this direction, the first quadrant is this one. Okay, this is actually called as first quadrant, and remember, you have to number the quadrant by the Roman letter, don't use a Hindu Arabic number. So remember, very important thing, always number the quadrant, mention the quadrant by Roman letters only. Remember, Roman letters. first one. Okay, if you move further, okay, in the anti-clockwise direction, this is the second quadrant. Okay, so now look at here, quadrant number second, okay, or second quadrant. And if I continue like this, okay, I will move on to here, and this is actually what, third quadrant. And if you move like this, okay, now at last I will come here, and this is called as what, fourth quadrant. Okay, so first remember the different quadrants, and first, second, third, fourth. Okay, very important. Okay, next thing, I will move on to the next point. It's like this: each point in the Cartesian plane is identified by means of two coordinates called as x coordinate, it is also called as abscissa, and y coordinate, it is also called as ordinate, and denoted in general x comma y. Okay, so now this is very important thing. Okay, locating a point in the coordinate system. So now look at here. So for this one, I'm going to consider one more figure for you. Okay, so now just look at this figure. Okay, so now just look at this figure. Actually, I have considered what 3 comma 2 here. Okay, so I think the same point is actually mentioned in this figure. Now look at this figure. Okay, so look at this figure, 3 comma 2. Actually 3 comma 2 means this is actually the position, and this position, the coordinates of this position is actually what, 3 comma 2. 3 comma 2. Now let us see how, why it is a 3 comma 2. So now look at here. Now at this point, okay, if you draw two lines like this, okay, if you draw the line like this, means the line which is perpendicular to x-axis, it will meet here. Okay, actually this is 2 on the x-axis. Okay, now I think this is actually what, 3 comma 2, 2 comma 3. I think it's difficult to understand in this figure, so that's why I will move on to the next figure. Okay, so now just look at here, I will move on to the next one. Okay, so just look at here, it will be very familiar for you. So in this figure, so now look at here, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6 actually. Okay, and this is 1, 2, 3, 4, 5, and this center portion is actually 0. Okay, so now look at here, the position of this point. Okay, how to identify the position of this point. So now look at here. So if you come in this direction like this, means in the direction perpendicular to the x-axis, you will reach here. Okay, so from this point, if you come perpendicular to the x-axis, you will reach here. Okay, so this is actually what, 6. So that's why this x coordinate will become 6 for this point. In the same sense, if you move in this direction, means in the direction perpendicular to the y-axis, you will reach here. Okay, so at this point, this actually corresponds what, to on y-axis. That's why its y coordinate is actually what, 2. Okay, so just try to understand here how to look at the position of a point in the Cartesian plane. Now look at here, this is actually the point. Okay, so if you draw the perpendicular line to x-axis, it will meet at x. That's why this is actually called as what, x coordinate of the point. In the similar sense, if you draw the line which is perpendicular to the y-axis, it will meet the y-axis at 2. So that's why its y coordinate become what, 2. Okay, in the similar sense, you can identify the position of the remaining points also. I have added one more figure for you, and just look at here and try to understand in this figure all the things. Now look at here, this is actually the position. If you draw the line perpendicular to the x-axis, you will reach here. Okay, 2, its x coordinate is 2. And if you draw the perpendicular to y-axis, you will meet here. Okay, so this is actually position between 1 and 2. Okay, middle position. So middle position means between 1 and 2, the middle value is actually what, 1.5. So that's why this corresponds 1.5, but it is not written here, but you have to understood. Okay, it's 1.5. So that's why its y coordinate is 1.5. And one more thing, you can look here, L. Okay, if you draw the perpendicular to x-axis, it meets at -3. Okay, so that's why x coordinate is -3. So and if you draw the perpendicular, then it will once again intersect at 1.5. So that's why it will become what, y coordinate become 1.5. In a similar sense, okay, now look at here, one more point is present, n. Okay, so if you draw the perpendicular to x-axis, first thing, remember, first you have to draw the perpendicular to x-axis and then y-axis. Then means you need to write on first x coordinate, then y coordinate. If you write on first y coordinate, then x coordinate, it is a wrong representation. Remember, very important thing. first you have to write on x coordinate and then y coordinate. Okay, so that's why first I'm going to consider the perpendicular to x axis. That's why. Okay, so now look at here, from this point perpendicular to x axis means it reaches at -2, so that's why its x coordinate is -2. And if you draw the perpendicular to y axis, it reaches at -3, so that's why its y coordinate is actually what, -3. Okay, so this is the easiest way. Okay, I think you have understood how to locate the position of a point in the Cartesian coordinate system. You have solved these type of problems in the previous year, but I am going to recall once again for you. Okay, so I think you will become very familiar about this one. Okay, now look at here, always enclose the coordinates within the bracket. If you don't write on the bracket, so it's actually a wrong representation. Okay, no marks will be given for you. So if you write on the coordinates without bracket, you may lose the marks. That's why remember the representation, correct way of representation. After writing the coordinates, you have to enclose within the bracket. Okay, so now look at here, brackets. Okay, from initial bracket and final bracket. Okay, this is open and this is closed. And remember one more thing, after writing the x coordinate, put a comma here. Okay, and then write on the next coordinate. And the first coordinate what you have written, it is actually called as x coordinate, and alternative name is abscissa. Remember this one. So many students are always using the word x coordinate. They may not know about what is abscissa actually. Okay, so that's why it's a very important thing. Remember, abscissa means it is x coordinate. Okay, and in the same sense, 1.5 is y coordinate. Y coordinate is nothing but ordinate. Okay, abscissa and ordinate are the two alternative words for x coordinate and y coordinate alternatively, and remember these two alternative names also. Okay, so now I will move to the next point. So now look at here, here I have given an example for you, 3, 2, here 3 is actually abscissa and 2 is actually what, ordinate. Okay, and coordinates may be positive or negative or 0. Okay, so I think you can clarify this thing here. Okay, so now look at here, so here the coordinates both are positive, here negative, this is positive, and here both are negative actually. Okay, so coordinates may be positive, may be negative, sometimes may be 0 also. Remember, sometimes may be 0 also. So 0 will appear whenever the point lies on the axis. Okay, I'm going to add this point later. Okay, I'm going to clarify this one in the next point. Okay, now look at here the next point. X coordinate indicates the perpendicular distance of the point from the y-axis. So y coordinate indicates what, perpendicular distance of the point from the x-axis. Okay, so just try to understand this one. X coordinate means it is the perpendicular distance from the y-axis actually. Reverse thing. Okay, x coordinate distance from y-axis, y coordinate distance from x-axis. Okay, just you have to say perpendicular distance. It is very important. Okay, mention this one, perpendicular distance. X coordinate means perpendicular distance from y-axis, y coordinate means perpendicular distance from x-axis actually. Okay, just remember this one, because this type of sentences may be asked in 1 mark question, so that's why I'm going to add here. Okay, so now look at here, this is very important thing, sign of coordinates in different quadrants. Okay, you have studied this one in the previous year also. Once again I'm going to recall for you. In the first quadrant, both x coordinates and y coordinate are actually positive, positive. In the second quadrant, x coordinate is negative, y coordinate is positive. And in the third quadrant, both coordinates are actually negative. And in the fourth quadrant, x coordinate is positive, y coordinate is actually what, negative. Okay, so this is very important sign convention, and it is mentioned in this figure. Okay, so now look at here. Now look at in this figure. So in the figure, okay, first quadrant both are positive, second quadrant negative and positive, third quadrant negative, fourth quadrant positive, negative. Okay, remember this one, sign convention, very important. Okay, so and the last thing is, now look at here, general form of a point which lies on x-axis is x, 0. and if it lies on y-axis, it will be of the form y comma 0 actually. Okay, so this is very important thing. If it lies on x-axis and y-axis, actually in this figure I have mentioned no point which lies on the axis, but I'm going to clarify for you. Okay, so now look at it in this figure. So just if you consider this point, okay, means I'm going to consider the point on axis, okay, exactly at 1 on the x-axis. The coordinates of this point is actually 1 comma 0. Remember, 1 comma 0 means on the x-axis x coordinate will be present, y coordinate is absent, means 0. Absent means in the sense of 0. Okay, so the coordinates of this point is 1 comma 0. Coordinates of this point is 2 comma 0. Coordinates of this point 3 comma 0. Coordinates of this point 4 comma 0, like that. Okay, so but if you come here, okay, minus 4 comma 0, minus 3 comma 0 coordinates, minus 2 comma 0, minus 1 comma 0, this is obviously known for you, 0 comma 0. Okay, and when we move on to the y axis, okay, if you have point present on y axis, it will be of the form what, 0 comma y. Okay, so now look at here, sorry, okay, I forgot to change this one actually. So this will be of the form what, 0 comma y. Okay, so remember this one. Okay, 0 comma y actually. So x comma 0 and 0 comma y. So now look at it, 0 comma y means if you consider this position, okay, the position of this point is actually what, 0 comma 1, not 1 comma 0. If you say 1 comma 0, and the position of this one is also 1 comma 0, 1 comma 0. Okay, both position will become same. Okay, it will not happen in the Cartesian plane. Every position has unique coordinates, remember. Okay, so that's why if you say this is 1 comma 0, it's actually wrong, definitely wrong. So it's actually what, 0 comma 1. 0 comma 1 means on the y-axis only y coordinate is present, x coordinate is absent, in the sense it is 0. Remember, very important thing. So coordinates of this point 0 comma 2, 0 comma 2, and coordinates of this point 0 comma 3, coordinates of this point 0 comma 4, in the same sense in the negative axis 0 comma minus 1. Okay, 0 comma minus 2, 0 comma minus 3, 0 comma minus 4, like that. Okay, so just to try to understand the thing, if it lies on x-axis, only x coordinate will be present, y coordinate is 0. And the second thing, if it lies on y-axis, only y coordinate will be present, x coordinate is actually what, 0. Remember, very important thing. Okay, so that's why okay, if you learn all these things, it completes the basics of Cartesian plane. Okay, so what we have studied till now, so it is made of two number lines. Okay, they are mutually perpendicular to each other, and they are going to intersect at the at their origin means 0, and the point of intersection is called as that is, it is called as origin. Coordinates 0 comma 0. There are 4 quadrants, 1 2 3 4, okay, in the anti-clockwise direction, and signs in different quadrants, and the general form when the point lies on the x-axis or y-axis, like that. Okay, so these are all the important things, means basic things regarding the Cartesian coordinate system or Cartesian plane, or it is also called as xy plane. Okay, remember all these names. Okay, it is very important. So that's why these are all the basic things, and you have to write down all these things in your notes. Okay, I'm not going to give the PDF notes for you, just you need to pause the video and you have to write on this one. Okay, so once, or otherwise I will send this one. Okay, so don't write down, don't pause the video while watching this one. I'm going to send this one through the WhatsApp or Google Classroom. Okay, just watch this one and then you need to write on the notes. Okay, after complete watching this video. Okay, so then in your notebook, just you need to write on this one. Okay, write on this figure. Okay, this figure and this figure, last one. Okay, this one. Okay, only two figures you need to write on in your notebook, so don't write this figure. Okay, so this is only for understanding purpose. Don't write on this one and this one also. Okay, you need to write on this figure. Okay, this figure and this figure. Okay, you have to write on these two figures in the graph sheet only, remember. Okay, so take a graph sheet, piece of graph paper, and write on this coordinate plane, and this figure, 3 points are actually located. Write on in the graph sheet and paste this one to your notebook. Okay, so because if you write on this one in the graph sheet, it will be very familiar for you. Okay, the concept will become very familiar for you. Okay, you need to practice this one on the graph paper only, so that's why I mentioned for you. So write on these two graphs in the graph sheet only, don't write on in the notebook. And keep a white notebook for this one. Okay, because it is related to geometry, it is better if you put white notebook for you, means unruled notebook for you. Okay, so now I will move on to the next concept of this chapter. Okay, so next concept means this is actually the first topic in this chapter. Okay, distance formula. Okay, so now look at here. Actually, we are going to study what three important topics. Among the three, one is already deleted. Okay, forgot about this one. And this is distance formula, and this is what section formula. First, I'm going to deal with what distance formula, and later I will move on to what section formula. Now let us begin the first topic, distance formula. Okay, so first thing is we have to understand what is the meaning of distance. It is very familiar for you. Distance means what? Means you are going to measure the length from one point to another point. Okay, it is actually called as what? Distance. Okay, you have studied this one in your physics actually. Okay, distance, displacement, like that. Okay, so distance means it is always what? Straight line distance. Okay, we have to consider in a straight line manner. Okay, so now we are going to study the distance. Means I think you are getting some idea about this concept. Okay, so now in the Cartesian plane, okay, whenever 2 points are given to you, okay, two different points are given to you in the Cartesian plane, you are going to measure what is the distance between those 2 points. So it's not always possible to, okay, one method is there. Okay, the traditional method is actually what? Just by using the scale or a measuring instrument, you can measure what is the distance between those 2 points. Okay, it's one way. And but in this chapter we are not going to deal like that. Okay, so measuring instruments, it's very easy. Okay, everyone can do that one. Okay, what is the distance between two different positions by measuring the distance by using measuring instruments, we can understand what is the distance between those two. But in this concept we are not going to use any measuring instruments. We are going to use what? Formula, mathematical formula. So means we are going to measure the distance between two different positions in a coordinate plane by theoretical calculation. Okay, for theoretical calculation we must have one formula. Okay, first I'm going to introduce the formula for you. Means the derivation. It's a simple derivation. If you know the Pythagoras theorem, okay, you can understand this one. Okay, but it is already familiar for you. Okay, in the 9th standard also you told the statement of the Pythagoras theorem. If you know that one, then you can immediately understand this derivation. Okay, now look at the derivation. It is actually like this distance formula. So now let P of x1 comma y1 and Q of x2 comma y2 be 2 points in the Cartesian plane. Means in the general sense, I'm going to consider here in the general sense. That's why I'm going to consider x1 y1 x2 y2 like that. Okay, 2 points, P and Q are the 2 points. Now look at the figure also carefully. So now look at here, this is actually the point P having coordinates x1 y1. Okay, so this is a figure which is similar what they have given in your NCERT textbook, but just I'm going to modify something. Okay, I'm going to add something. Okay, just look at the figure, you can understand later. So now look at it, this is the point P having coordinates what? X1 y1. Okay, and this is the point Q, and it has coordinate x2 comma y2. Now I want to measure what? Distance from P to Q. I want to measure this one. What is the distance from P to Q here? Okay, so I'm going to derive the formula to find out the distance between P and Q. So now look at here. Now I'm going to make some construction for this one. Let join P and Q. Okay, it's already joined. Okay, P and Q, and draw PR perpendicular to QS. Okay, it's already drawn. Okay, now look at here. PR. This is the perpendicular to what? X-axis, and this is what QS. This is perpendicular to what? X-axis once again. Okay, now look at here. This angle 90 degree. And this angle is also equal to 90 degrees, so that's why they are perpendicular. Okay, and the next thing is draw PT perpendicular to QS. Now look at here, this is the point P. PT is perpendicular to what? QS. Okay, try to understand here. PT is perpendicular to QS. Now look at here, this angle is equal to 90 degrees. Okay, I think now you can observe a right angle triangle here. Okay, one right angle triangle is formed here. So now look at here, P, Q, T. This is a triangle. Okay, moreover, what type of triangle it is? Right angle triangle, where it is located 90 degree at the point T. Okay, PTQ. It is actually what? 90 degree, and hence PQT is a right angled triangle, and you need to apply the Pythagoras theorem here. Okay, if you apply the Pythagoras theorem, then it will be enough. Before that, we have to understand something. Okay, so now look at here in this figure I'm going to give for you. It is like this. Okay, just you need the figure for. Okay, so now look at here. OR is equal to x1. Okay, now try to understand the things here. It's very important. Now look at here. O to R distance is x1. So this is because the x coordinate of the point P is actually what? X1. So its x coordinate is x1, means if you draw the perpendicular like this, and this position is actually corresponds what? X1. I think you have clarified this one in the previous figure. Now look at here. So the coordinates m are actually 2, 1.5. Okay, so now look at here. 2 is the x coordinate. Okay, if you draw the perpendicular, okay, so this will reach at 2. Okay, this is actually what? X coordinate. And if you draw the perpendicular to y axis, it will reach here. This is actually what? 1.5 y coordinate. Similar thing. Okay, the same thing will happen here. Look at here, its x coordinate is actually what? X1. If you draw the perpendicular, it will reach here. Okay, this is actually x1. Okay, means from here to here distance is x1. Total distance, O to R, total distance is x1. And the same thing, if you draw the perpendicular to y axis, it will correspond to what? Y1. So therefore from here to here total distance will become what? Y1. Similar thing, okay, if you draw the perpendicular to QS to x-axis, O to S, total distance is x2. Okay, I have written here. Okay, this is total distance. Okay, this is, I'm going to shift this one above. Okay, just wait for a second. Okay, this is x2 minus x1. I'm going to explain this one later. So now this is actually what I'm going to shift this one above, and so now look at here. This is actually, this line corresponds to the distance from O to S actually. Okay, O to S, and its distance is actually how much? It is equal to x2, because the x coordinate of Q is actually what? X2. That's why distance from O to S is equal to how much? X2. By this we can understand distance from O to S is larger than distance from O to R. Okay, it is a common thing. Just by observing the figure we can understand that one. Okay, x2 is greater than x1 actually. Okay, so now in the same sense, O to this point. Okay, so distance is y1, and O to this point. I'm not going to mention the points because it is not necessary. I'm going to assign the letters for this position. It's actually not necessary for you. That's why. Okay, O to this point, distance y1. O to this point, total distance is y2. Okay, I have written that one here. Okay, so this is the total distance. Okay, so now by just observing we can understand y2 is greater than y1. Distance y2 is greater than distance y1. And now look at here. Now I want what is the distance from R to S. Distance from R to S. Okay, distance from R to S you can obtain like this. If you do like this, OS, okay, OS minus OR. Okay, in this total distance from here to here, if you subtract this distance, you will get the remaining is like this. Means OS minus OR, you will get what? RS. Okay, try to understand here. So that's why what is the distance from O to S? It is x2. What is the distance from O to R? It is x1. x2 minus x1 will give the distance from R to S, that is RS. So that's why I have written here OR is equal to x1, OS is equal to x2, RS is equal to x2 minus x1. This distance is x2 minus x1. In a similar sense, in the case of y-axis also. So now look at here, I want this one. Okay, this is the distance. Okay, this distance is actually what it is. It will be same as QT. Now look at here. Try to understand the figure first. QT and distance from here to here, both are same actually. Okay, it is clear from the figure. So that's why, what is this distance? How can you define this one? Total distance from here to here, y2. Okay, so from here to here, y1. Subtract this one, y1. You will get what? y2 minus y1. So that's why this corresponds what? y2 minus y1. That's why qt is equal to y2 minus y1. I have written this one here. Qt is equal to qs minus ts. Okay, actually I have written like this. Qt is equal to qs minus ts actually. So TS and then PR both are one and the same. TS, PR and then distance from here to here all are same. It is equal to I1. Okay. So that's why I have written it is equal to TS is same as PR. Okay. And then QS means what? From the figure you can understand. QS means this is the total distance from here to here. Okay. It's actually what? Y2. Okay, y2. And then distance from T to S or P to R. Okay, P to R means this one. Okay, this is equal to what? Y1. Okay, so that's why I have put Y1. Okay, it will become what? Y2 minus Y1. Okay, so now we have got what? Now look at here. Try to understand one more thing. Here RS is equal to X2 minus Y1. R to S length and P to T length will be same once again. It's clear from the figure. Okay, look at the figure. Distance from R to S, distance from P to T, both are one and the same. So that's why we can treat RS is equal to PT. Okay, therefore RS is equal to x2 minus x1 means PT is also equal to x2 minus x1, and also QT is equal to y2 minus y1. Okay, so now look at here. Now apply the Pythagoras theorem in triangle PTQ. We get what? Okay, now look at here. PTQ is a right angle triangle. So here hypotenuse is what? PQ. PQ is the hypotenuse, and the next thing is this is actually the 90 degrees. So that's why angle opposite to the 90 degree is actually what? Hypotenuse. So that's why if you apply the Pythagoras theorem, you will get like this. PQ square is equal to, means hypotenuse square is equal to sum of the squares of other two sides. That's why PQ square is equal to PT square and QT square. Okay, PQ square is equal to PT square plus QT square. So that's why I'm going to write on the same thing. PQ square is equal to PT square plus QT square. I want what? PQ actually. PQ is actually what? PQ is the distance from P to Q. Okay, my intention is actually what? I'm going to find out what is the distance from P to Q, and it is denoted by PQ. PQ means distance from P to Q. But here it's actually PQ square. Okay, I will later move the square towards the right side. Okay, now just I'm going to substitute here. PT is equal to, okay, now look at here. So I told for you RS and PT both are one and the same. Okay, so that's why in the place of PT I'm going to place RS. RS means what? X2 minus X1. But here square is there. That's why X2 minus X1 whole square. Then QT means y2 minus y1, but QT square is present here. That's why it will become y2 minus y1 whole square. This is square. I think it's not clearly visible for you. Just try to understand here square is present. Okay, so now here's the square is there. Okay, if you shift the square towards the right side, it will become what? Plus or minus square root of. Okay, but I'm not going to mention plus or minus. This is because PQ is what? Distance. Distance is always a positive quantity. You have studied this one in the physics. Okay, in your physics subject, distance is always a positive quantity. Distance is a negative, means meaningless. Okay, it has no meaning. So that's why I'm not going to write on plus or minus. Okay, I'm not going to write on anything means plus is present. Okay, that is distance is positive. Square root of x2 minus x1 whole square plus y2 minus y1 whole square as it is. Okay, so now this is actually the final formula. This is called as a distance formula. Remember, this is actually the required formula. So distance from P to Q can be measured like this: square root of x2 minus x1 whole square, y2 minus y1 whole square. So what is x1, y1, x2, y2? x2, x1, y1 are coordinates of P. X1 is X coordinate, Y1 is Y coordinate of P, and X2 comma Y2 are X2 is X coordinate of Q, Y2 is Y coordinate of Q. So if you know the coordinates of both P and Q, and on substituting in this formula and on simplification, you will immediately get what is the distance between P and Q. Okay, so this is actually the theoretical formula to find out the distance between the 2 points. One, its coordinates are given to you. You must know the coordinates. If you don't know the coordinates, it is impossible to find out the distance between those 2 points. Okay, so that's why you must know the coordinates of those 2 points, then only you can find out the distance between those 2 points by using the distance formula. Okay, so now I'm going to convey for you one more important thing. Okay, so now look at here, note that since distance is always non-negative, I told for this one already for you, we take only positive square root. Okay, I told for this one already for you. Okay, and so the distance between P of x1 y1 is equal to like this. Okay, positive value, and this called as what, distance formula. And one more important thing, so the next thing in particular, this is very important, remember, the first remark is very important. In particular, the distance of a point P of x comma y from origin, that is O 0 comma 0, is given by OP is equal to square root of x square plus y square. Okay, so try to understand here. Now if you let us treat this one as x1 y1, okay, and this one as x2 comma y2. Okay, if you treat this one as x1 y1 and this one as x2 comma y2, x2 is actually what, 0, y2 is 0. Okay, and x1 means x, y1 means y. Okay, if you substitute this one in this formula, now let us see what will happen. Now look at here, x2, this is x2. Okay, so now x2 means this is actually 0. Okay, instead of that, it's better, I think, if you take this one as x2 comma y2 and this one as x1 comma y1. You can choose whatever the point. Okay, among the 2 points, you can choose any point as x1 y1 and another one as x2 y2. Okay, if you choose this one, okay, I'm going to consider like this. This is x2 comma y2, this is x1 comma y1. Okay, so now look at it, x2 means what, x minus x1. X1 means what, 0. It will become what, x minus 0. X minus 0 means x itself. Okay, but square is there, it will become what, x square. That's why x square. And then second thing, y2 means this is actually y2. Okay, y2 means it's y actually now. And then minus y1 means what, 0. So it will become what, y minus 0. Y minus 0 means y itself, but square is there, it will become what, y square. So that's why distance of any point from origin is very easy. Okay, the calculation is very easy. Just if you square the coordinates, then add and apply the square root.